Hi there, this is Jacob, and this is the video for my final project for CSSE120. Here on my floor, you can see we have the robot that we've been working with, and lined up with it is the cube that it is going to drive to and pick up. And here you can see two locations marked out on the floor, one that says left switch and one that says right switch, because after it picks up the cube, the robot will either turn left or right depending on which mode I have selected and put it in the switch. This is based off of the first robotics competition for 2018, first PowerUp, because I was in first robotics, so I felt like it'd be a really fun thing to try to do because I just noticed a lot of the similarities. So let's take a quick look at the code. First of all, I have everything run onto the robot already. It's done all of its configurations, so the quad doesn't need to move until I've run what I actually created. But here you can see the runs on laptop option where you have the main method where it sets up the root, it sets up the communications with the robot, and it sets up the GUI, and then it runs the main loop, which allows everything to do what it needs to do. Here in the setup GUI method, you actually see the frame, the speed entry box where I can input the speed the robot goes at, and left autonomous and right autonomous buttons, which determines which autonomous the robot will run. And here you see the autonomous methods that take in the speed, and those are what gets sent to the robot. Here in the actual runs on robot method, you see that you have the comm setup that connects to the PC. And then you have the remote control method, which is what tells the robot to do what. So you see that I have left and right autonomous methods here as well, where it takes in the speeds that I input through the GUI, and it makes the robot start running at that speed. And then you see that I have move to left and move to right switch methods, and those do nearly the exact same thing as each other because both of them are meant to be almost exactly the same. The only difference is that when the robot turns, one is in a positive direction and one is in a negative direction. So here you can see that the robot drives normally until the proximity sensor picks up on the object a certain distance away, and then it drives the remainder of that distance and closes the claw, picks up or moves the arm up, turns, and then it drives to the switch, and then it puts the object down. So let's go ahead and go to the GUI and start to run the process. So you can see that it's very simple, really. It's just a simple box where I have a entry box to put in the speed. Let's go ahead and make it 30 so it's not too fast or too slow. And I can select either left or right autonomous. The right autonomous has been more friendly to me, so let's go ahead and use that. So I will go ahead and press the button, and then we can watch it from here. So the robot goes forward at the set speed, but then once it gets closer, it picks up on the cube being nearby. And then the claw picks up the cube, and once it gets to the top, then it turns, and then it drives. And then once it's gotten the distance that I told it to go, then it puts the cube down, and then it opens its claw. And I could take more time to show it on the left, but it works just as well over there because, like I said, all the code does is just have a negative sign. And to prove it, let's actually go ahead and look at that. So here you have the move to left switch method, and here you have the move to right switch method, which I have minimized. But everything is still the same. But then for whenever I have the robot start to turn, this one says 50, negative 50. This one says negative 50, 50. So it would do the same thing, very simple forward. So that is it for the project. I hope that you enjoyed it, and I hope that it was very well thought out. I really enjoyed doing the whole project, so thank you.